Hello all, let's start section 3.4. 3.4 is about zeros of polynomial functions. The first topic that we will discuss here, the rational zero theorem. What are the zeros of a polynomial function? Even we discussed it before. If I have, for example, a polynomial function, let me graph a function here for you, maybe something like this. Let's say this is a polynomial function, the graph of one of polynomial functions. The x-intercept of your graph, we called it the zeros of the function, correct? And we discussed it before, how to find the zeros. The only method that on that time you used was factoring. But if you remember, I told you there are some polynomial functions that even we don't know how to factor. They are higher degrees and we don't know how to factor them. Then there is another way to find those zeros. Now, the first topic, the rational zero theorem, let me explain to you what is the rational zero theorem. A polynomial function, we discussed it before, is in the form of f of x equal a n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus dot dot dot, and you end up with a1 x to the power of 1 plus a0, your constant term, correct? We named a sub n the leading coefficient and a0 is your constant term, correct? Now, the rational zero theorem is talking about finding all possible zeros. Remember, all possible zeros of a polynomial function. This theory talks about how to find all possible zeros. When I'm saying possible zeros, it means that when you list all those numbers, all of them cannot be your zeros like this. All of them is not your zeros, but your zeros of polynomial is definitely in that list, correct? Now, how to find the possible zeros of a polynomial function? The possible zeros of a polynomial function is the ratio of p over q. Now, what is p? What is q? I'll explain it to you. P is all possible factors of the constant term. P is all possible factors of a0, which is your constant term, and q is all possible factors of a sub n, your leading coefficient, correct? Even some professors are telling you this way. A0 over an gives you the all possible zeros of a polynomial function, but all possible factors of E0, correct? Not just A0 over an, not just the constant over the leading coefficient, all possible factors of them, correct? Giving you the possible zeros of your polynomial function. Let me explain it now in a numeric example, correct? I'll copy this example from your book. Example number 1. List all possible rational zeros of f of x equals negative x to the power of 4 plus 3x squared plus 4. They're asking you to list all possible zeros of this polynomial function. Few things, how to go step by step. First, what is your a0 or what is a sub 0, your constant term? How much is that? That's 4, right? What is the leading coefficient, a sub n? How much is a sub n? Negative 1. Now, what are the possible factors of 4? I think it's a topic from the beginner math that you can find all possible factors of a number. It means which numbers can multiply with each other that gives you positive 4, correct? Or 4 can be divided by which numbers, correct? The possible factors of 4 will be plus minus 1. Any number can be divided by 1, correct? 4 can be divided by 2, positive, negative 2. And 4 can be divided by 4, correct? These are the list of possible factors of your constant term, or a sub 0. What are the possible factors of negative 1? The possible factors of negative 1 is plus minus 1. Correct? Now, how to find the possible zeros? The formula for possible zeros equals P over Q, right? Which means your P is plus minus 1, plus minus 2, plus minus 4 over plus minus 1. It means if I write separately for you, plus minus 1 over plus minus 1, it's one of the possible zeros. Plus minus 2 over plus minus 1, it's another possible zero. And also plus minus 4 over plus minus 1. And if you divide, correct, any number divided by 1 gives you back the number. Then you can say my possible zeros for this function is plus minus 1, plus minus 2, and plus minus what? 4. If you see the graph of this function, I don't want to graph it here for you, correct? But if you see the graph of this function, the graph of this function actually has a 0, a positive 2, and negative 2. If I draw here the function for you, just show the shape, not exactly the graph. If you have a TI-84, you can graph it there if you know how to graph. 1, 2, at 2, this function has a 0, and at negative 2, this function has a 0. Remember when we discussed the end behavior of a graph? This function is your exponent is even and the leading coefficient is negative, right? It means this side goes down, comes up somehow, the shape is like this, and goes back down here. The shape of this graph is actually, if you graph it, is like this. And you see the actual zeros or the real zeros are at 2 and negative 2, which you have it in the list of possible zeros. 4 and negative 4 is not the zeros of this polynomial function. Positive 1, negative 1 is not the real zero of this function. The real zero is at 2 and negative 2. But what this theorem helps us with, it gives us an idea that, hey, your real zero is between these numbers. If you want to look at the rational zero or at the real zero, check with this list. Not all numbers. There are infinite numbers. Which one I can check? It gives you a list. And we call that list the possible zeros of a polynomial function. Let me do another example. Then we go and talk about the real zeros of a polynomial function. But let's do first another example. Example number 2. List all possible zeros. List all possible zeros of f of x equals x to the power of 5 minus 2x cubed plus 3x squared plus 4x, let's say, plus 6. I want to list all possible zeros. My first step, looking for the a sub 0. How much is my constant term? My constant term is 6. Correct? A sub n, leading coefficient. My leading coefficient is 1. The coefficient of x to the power of 5 here. Correct? Now, what are the possible factors of 6? Possible factors of 6 can be plus minus 1, plus minus 2, plus minus 3, and plus minus what? 6. Possible factors of 1 can be only plus minus 1. Now, possible zeros, equals P over Q, which means plus minus 1, plus minus 2, comma, plus minus 3, comma, plus minus 6 over plus minus 1. And any number divided by plus minus 1 gives you back the number. It means your possible zeros will be plus minus 1, plus minus 2, plus minus 3, and plus minus 6. These are the possible zeros of the given polynomial function. Which one is the real? I don't know. But now we are learning how to find the real zeros of a polynomial function. But first you have to get enough practice, and you see the process is really easy how to find the possible zeros of a polynomial function. Just remember, the possible factors of or all factors of your constant term over all factors of your leading coefficient gives you the possible zeros of a polynomial function. Correct? Now, let's discuss finding zeros of a polynomial function. Possible zeros was easy. Now, how to find zeros of a polynomial function? In some books, they are calling it real zeros. but it's better to call it in general zeros, because sometimes you get some zeros that they are not real, correct? They have involving I in it that soon you will see. But the real zeros, the zeros that the polynomial function actually crossing the x-axis, the x-intercept, we call it the zeros of polynomial function in general. How to find? To find the zeros of a polynomial function, you do it in two main steps. Step number one. Find all possible zeros of a polynomial function. That's your step one, which you already learned it, how to find all possible zeros. Step two, and step two, you can use a synthetic division or long division to find the real zeros or the zeros of a polynomial function. Correct? And step two, I can write for you, do this. Use synthetic division to find zeros. Remember, there was a theory that we studied before, that the remainder theorem. If the remainder of a polynomial function after you divide becomes zero, that number is actually a zero of a polynomial function. That's why we are looking, and that's easy. That's why you're learning on all these theories to use them, correct? Now, if I explain it like in a lecture like this, it may get difficult for you to understand what I'm talking about. Let's do a numeric example and see how you can find the zeros of a polynomial function. Example, let me copy something from your book. Find all zeros. Find all zeros of f of x equals x cubed plus 2x squared minus 5x minus 6. Look for the zeros of this polynomial function. Step one, I look for the possible zeros. A sub 0, my constant term, is negative 6. And A sub n, the leading coefficient, is 1. The possible factors, or all factors of negative 6, is plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Possible factors of 1 is plus minus what? 1. Now, possible zeros, equals plus minus 1, comma, plus minus 2, comma, plus minus 3, comma, plus minus 6 over plus minus 1, which gives you plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Now, step 2. I'm using synthetic division to find the zeros. It is a long process. You have to use synthetic division with all these numbers that you have, with all possible zeros. You see how many numbers I have? Plus minus 1, 2 number here, plus minus 2, 4, plus minus 3, 6, plus minus 6, gives you 8 numbers. I have to do my synthetic division maybe 8 times to find the real zeros of a polynomial function. How? You just start with one of them. You are lucky if the first one works for you, or the second one works for you, or the fourth one works for you. But you have to check which one is actually the real zero. Look, if I write the polynomial function here for you, my polynomial function was f of x equals x cubed plus 2x squared minus 5x minus 6. And if I do synthetic division, the coefficients are 1. Let me start here. 1, 2, negative 5, negative 6. What I do here, I'll choose one of the possible zeros and I do the synthetic division. Let's choose, for example, positive 1. Correct? You are choosing how to do the synthetic division? Divide your polynomial function by the possible zeros and see the remainder of which possible zero becomes 0. That's the actual zero. Correct? Let's do synthetic division. We know how to do that. Bring down 1. 1 times 1 gives you 1. 2 plus 1 gives you 3. 1 times 3 gives you 3. Negative 5 and 3 gives you negative 2. Negative 2 times 1 gives you negative 2. Negative 6 and negative 2, negative 8. That's your remainder, correct? It's not a 0. Then 1 is not a 0 of a polynomial function. You can put a cross on it. Next time, use the next number. Same thing. 1, 2, negative 5, negative 6, divide by negative 1. I want to check my negative 1, correct? Let's do the synthetic division. 1 times negative 1 gives you negative 1. 2 minus 1 gives you 1. 1 times negative 1 gives you negative 1. Negative 5, negative 1 gives you negative 6. Negative 6 times negative 1 gives you positive 6. Negative 6 and positive 6 gives you 0. Wow! Here you go. Here you go. Your remainder is 0. It means negative 1 is one of the factors of this, or one of the zeros of this polynomial function. Correct? Your negative 1 is one of the zeros of this polynomial function. Okay, as soon as I found one of them, I will try to factor it. I don't want to use synthetic division to find all of them. It's a lot to do. At least I know one of my zeros. When x is equal negative 1, if this is the zero of my polynomial function, then my factor will be x plus 1. Agree? Because if you put x plus 1 equal to 0, it gives you x equal -1, which is the 0 of polynomial function, correct? Then one of my factors are what? X plus 1. What left here? Look, your polynomial function is started with x cubed. Here, this is x squared. This is x, and this is your constant term. It means you can write that polynomial function as a x plus 1 times x squared plus x minus 6. Agree? Because we learn how to write here our function after division, correct? Now, can I factor x squared plus x minus 6? Let's try if we can factor, correct? Then x plus 1 times, I will open two parentheses, x and x, possible factors of 6 to add gives you -6 to add gives you x. Of course, +3 and negative what? 2. And if you set all of them equal to 0, x plus 1 equals 0, it means x equal -1, which you already have that one. That's one of the zeros of your polynomial function. X minus 2 equals 0, which is x equal 2. This is another 0 of the polynomial function. And x plus 3 equals 0. X equal -3 is another 0 of the polynomial function. It means these are the x-intercepts of your polynomial function. Correct? I told you in the theory that when you find the possible zeros, all of them is not your zeros, but your zeros are in this list. You see -3 is in your possible 0, 2 is in your possible 0, and -1 is in your possible 0. It means that list actually helps you to find the real zeros, or you just can call it the zeros of your polynomial function. Correct? Let me do another example also, at least 2 examples, correct? Don't complain that our professor is only doing one example. Example number 2. Again, find the zeros, correct? Find all zeros. And the function is given to you as a f of x equals x cubed plus 7x squared plus 11x minus 3. They are asking you to find the zeros of your polynomial function. Okay. First, step 1. Possible zeros. A sub 0, your constant term is -3. What are the possible all factors of -3? Factors of -3 can be plus minus 1 and plus minus what? 3. A sub n, your leading coefficient, is 1. Possible factors of 1 is plus minus 1. Possible zeros, plus minus 1, plus minus 3 over plus minus 1, correct? Which gives you plus minus 1 and plus minus what? 3. Now, step 2, use synthetic division to find the zeros of polynomial function. Let's write our polynomial function again here. You have f of x equals x cubed plus 7x squared plus 11x minus 3, right? Now I'm using synthetic division to find the zeros. What are the coefficients? Let's list them. 1, 7, 11, and -3. Please be careful. If your polynomial function has a missing term, a missing exponent, please complete that one. If you do not complete, I already discussed it in when I taught you the synthetic division. If you don't complete, your answer is wrong. Be careful. Here I saw x cubed, x squared, x. Okay, everything is there. I just listed. But some of them have missing, correct? Be careful with the missing ones. Divide by, use one of your possible zeros. For example, let's use +1 first. Correct? Bring down this one down. 1. 1 times 1 gives you 1. 7 plus 1 gives you 8. 8 times 1 gives you 8. 11 plus 8 gives me 19. 19 times 1 gives me 19. Definitely here you get 16. Your remainder is 16. Then 1 cannot be your real zero. Let's test -1. 1. Oh, why I put a comma there? I don't need a comma. 1, 7, 11, -3. This time I'm using -1. Bring down 1. 1 times -1 gives you -1. 7 minus 1 gives you 6. -1 times 6 gives you -6. 11 minus 6 gives you 5. 5 times -1 gives you -5. -3, -5 gives you -8. It means -1 is also not your real zero, or not your zero, correct? Let's continue with synthetic division. 1, 7, 11, -3. It's fun, right? I know. When you're free at home and you have nothing to do, nowhere to go because of COVID-19, find a polynomial function in degree 11 and try to find the zeros, correct? It takes you like half a day to do that. It's a good kind of something to get busy with. Now, let's use this time maybe +3. Another possible zero, correct? Bring down 1. 1 times 3 gives you 3. 7 plus 3 gives you 10. 10 times 3 gives you 30. 11 plus 30 gives you 41. 41 times 3, 123. Which your remainder will be 120. Then 3 is not also the zero of polynomial function. I have one more option. 1, 7, 11, -3. Let's this time use -3. Correct? Bring down 1. 1 times -3 is -3. 7 minus 3 gives you 4. 4 times -3 gives you -12. Correct? 11 minus 12 gives you -1. -1 times -3 gives you 3. Wow, here, 0. Yes, then one of the zeros of the polynomial function is x equal -3, which the possible factor will be x plus 3, right? Now, using the technique of factoring, if one of my factors are x plus 3, because your function starts with the cube, then this number is x squared, this number is x, and this is your constant term. That means x plus 3 times x squared plus 4x minus 1. Now, I want to find all the zeros, correct? To do that, make it equal to 0. At least I know one of them. The only tricky part is, I know this part. I don't need to make it again because I already have it. set x squared plus 4x minus 1 equals 0, you can't factor this quadratic equation. You see, there is no such a number to gives you 4, to multiply gives you negative 1, to add gives you 4, to multiply gives you negative 1. Then what to do? Use the quadratic formula. X equals negative b plus minus square root of b squared minus 4ac over 2a. You see, math is like a chain. You have to remember everything. If I cannot factor a quadratic equation, I can use the quadratic formula, correct? Let's use it. Negative b, it means negative 4. Plus minus square root of 4 squared minus 4 times a, 1 times c, negative 1. Over what? 2 times 1. Which you can say x equals negative 4 plus minus square root of 4 squared gives you 16. Negative times negative gives you positive. 4 times 1 gives you 4. It means 16 plus 4 over 2. Which is equal negative 4 plus minus a square root of 20 over what? Over 2. But 20, square root of 20 can be simplified, right? The square root of 20, you can write it as a 4 times 5. Then you can write this one as a negative 4 plus minus square root of 4 times 5 over what? Over 2. Now you can take the square root of 4, right? Then x equals negative 4 plus minus square root of 4 is 2, correct? 5 stays under the radical over what? Over 2. And if you simplify, it gives you what? It gives you, you can write this way, negative 4 over 2 plus minus 2 radical 5 over 2, right? And you can cancel the 2's here. Then your final answer is negative 2 plus minus radical 5. Here you go. You got 2 more zeros. You got 2 more zeros. The first 0 that we found was negative 3. If you want to list them, the first one was negative 3. The second one is negative 2 plus radical 5. And the third one is negative 2 minus radical 5. These are the zeros of your polynomial function. And if I say, okay, if it was an equation, what are the solution of this equation? Here you go. These are also, if it was not given as a function, as an equation, you already had the solution set for your equation, correct? Because we discussed that the zeros of a polynomial function is the solution set of the equation of that function. If it's not a function, an equation, that will be the solution of that equation, correct? I will stop this video here because this lecture is a long lecture, 3.4 is long. I have to talk about 2 more theories. The first one is the fundamental theorem of algebra and also properties of roots of polynomial function. I will stop the lecture here and I'll do the rest in the second part of this video for you. I'll stop it and see you in the second part of this video.